And now we'll have a look at an example that is a mix of every type of normal curve problem we've seen in regards to the application. So we have regular normal curve applications in here, and we have an inverse normal curve application in here. Sometimes people have trouble identifying which type of problem is which. What I'd recommend doing here is pause the video, try to solve these for yourself, and then come back and I'll go through the solution with you. And this problem is saying, suppose student loans of employees at a company have an approximately normal distribution with a mean of 100,000 and sigma equals 25,000. Part A is asking us to find the percentage of employees with loans less than $100,000. Okay, so we'll start part A. Now the way we would start this is by drawing our normal curve. Our mean is equal to 100,000, so that's what goes directly in the middle. And they were asking us to find the percentage of employees with loans less than $100,000. So 100,000 is our mean, and they want us to find the percentage of employees that have less than $100,000 in loans. So that's exactly 1/2 of the curve, so this is just going to be 50%. Okay, so this one's easy to do if you know these facts about the normal curve. Now let's say you completely forgot about that fact. You could still do it on the calculator. Just remember this is negative infinity. So right, and on the tables, you wouldn't be able to look this up. You would have to remember that each half of the curve is 50%, which if you're using the tables or even drawing pictures and using the calculator, you need to know that anyway. Now, let's say you're using the calculator. We would go to normal CDF. Now, our lower limit would be negative infinity, but we're going to have to approximate this with a bunch of 9s. And make sure that you use a lot of negative 9s because our mean is bigger here. If you have a mean that's a larger number, you need to approximate infinity with even bigger numbers just so that, you're far enough away from whatever the mean happens to be. So we're going to put in a lot of negative 9s. Might go crazy, put in a lot of negative 9s. Then we're going to put in 100,000 for our mean. And then our standard deviation, which was 25,000. We hit enter and we're going to get 0.500000000, like something like that, 5, which is pretty much the same thing as 50%. Now part B is saying find the percent of employees with loans between $50,000 and $75,000. Oh, and another thing I forgot to say. So part A, we know this is a regular normal curve application problem because they're asking us to find a percent. They're not asking us to find a specific loan amount. See here they're asking us for a percent. In part B, they're also asking us to find a percentage. That's what tells us these are regular normal curve applications. Now we'll draw our picture for B. So B is saying between 50,000 and 75,000. So we start drawing our curve. Our mean is 100,000. 50,000 and 75,000 both fall below 100,000. So that tells us we are looking for this section of area over here. When we convert these to z-scores, they're both going to end up being negative, right? Because if we were to convert this to z, that's 0. If we convert this one to z, that's going to end up being -1. This one ends up being -2 as a z-score. So if we're using the tables, we just have to go look both of those numbers up, and then we're going to subtract because it's this type of area. So let's see, for 2, we got 0.4772, and then for 1, we have 0.3413. We subtract, and then we end up getting 0.1359 or 13.59%. Now, if we were to do this using the calculator, this is just normal CDF because it's a regular normal curve application. Our lower is 50,000. Our upper is 75,000. Mean is 100,000. Standard deviation 25,000. We hit enter and we end up getting a number that rounds to 0.1359. So again, we end up with 13.59%. Now we'll take a look at part C. Below what amount is 88.3% of the employees' loans at the company? So what tells us that this problem is going to be an inverse normal curve problem is the fact that they're giving us a percent. In parts A and B, they were asking us to find a percent. Now we're being given a percent, and they're asking what amount. They could have been more specific and said what dollar amount. That might have been more of a clue. But the big red flag is that they're giving us a percent. And if they're giving us a percent, they don't want us to find a percent. They want us to find a value relevant to the problem. So this one is going to end up being an inverse normal curve problem because they're giving us a percent. So again, the fact that we're being given a percent makes this an inverse normal curve problem. Now let's draw our picture for part C. What do they say? Below what amount is 88.3%? So that means 88.3%, more than half of the percent, is below some value. So 50% is below the mean, like we saw over here. If more than half of 50% is below some value, that means whatever that value is, it's going to be above the mean. And this is 0.883, this whole thing. We know this piece is 0.5, so we want to look up this piece so we can find it on the table. That's going to be 0.833 minus 0.5, which gives us 0.333. And we're going to look this up on the table. Okay, so we go to our z table and we try to find the closest thing we can to 0.333. Over here we see 0.334. That's the closest we're going to get. We're not going to get 0.333 exactly. So we go over this way and we see we get 0.9, and then we go up and we see it's 0.07. So here z is equal to 0.097. And we'll just make a note here, 0.334 was the closest. Okay, so now that we know what our z-score is, we can find our student loan amount. X is equal to z times the standard deviation plus the mean. And we end up getting X is equal to 124,250. So this would be $124,250. In the context of this problem, this makes sense because this value is higher than the mean, and we expected the value we got to be higher than the mean. If we were doing this using our calculator, well, they already gave us the area to the left, so it's not, too much more work. Right, our area to the left was 0.883, which is what they gave us. We input our mean and our standard deviation. And what the calculator gives is 124,152, and you can even round off to cents because they give a little bit more. So that would round off to 21 cents, which is pretty much the same thing we got if we use the tables. And now we'll look at part D, which is the last one. So here they're telling us if there are 1,000 employees, how many have loans above $125,000? They're not giving us a percent, so this is not an inverse normal curve problem. This is just a regular normal curve application where we have to find what the percentage of area is that's going to be above 125,000 or whatever z-score that becomes, and then figure out how many employees that is, in that amount based on the percentage under the curve there. So if we draw our picture for this, we know that 125,000 falls above the mean. So we're dealing with this piece of area over here. So we would first want to figure out what this area is, then multiply it by the number of employees to see how many there are. If we convert this to a z-score, we end up getting +1, just like, this guy as a z-score would end up being 0. So if we go look up 1 on our table, we end up getting 0.3413. So that tells us that's this piece of area. And then this piece of area is 0.5 minus 0.3413, which is 0.1587. And now if we do 0.1587, multiply that by 1,000 employees, that's going to be equal to 158.7. But remember, we can't have, like 0.7 of a person, so we could either round this up or down, and I would say it's going to be about 159 employees. Now let's say that we wanted to do this on the calculator. To figure out this piece of area, we would go to normal CDF. We know that 125,000 is our lower limit. Our upper limit now is going to be positive infinity because we're going off in this direction, so it's just a lot of nines. Then our mean was 100,000. Our standard deviation was 25,000. Then we would hit enter. We end up getting 0.15865, which rounds up to 0.1587, which when we multiply by 1,000 employees is going to give us the same thing. So 1,000 times 0.1587 is 158.7, which again tells us about 159 employees.